Today we're talking about polygons, poly meaning many and gonia meaning angles. So polygons are all about angles. It's a two-dimensional shape that's named after the number of angles and also the number of sides that it has. So what's really cool is we can find out the sum of all the angles of polygons based on what we know about triangles. So triangles, we know that all of these angles add up to 180 degrees. Triangle has three sides. And within a triangle, well, there's one triangle. So a triangle is 180 degrees. A quadrilateral, any four-sided or four-angled shape, can be chopped into two triangles if we connect these two points, vertices across from each other. Four sides, two triangles, 2 times 180, which is what the number of angles we know are in a triangle, gives us 360. So to get the sum of these different shapes, we go ahead and draw. We don't want to do, I'll give you an example of what we don't want to do. Don't want to draw a connection like that, because then that gives us something that creates more angles that we don't need. It's not going to help us figure out what we want. And so what we want is to just choose a single point to start from. They started from this point, go across to any of the other ones you can reach. These are already connected. You can see we have three triangles, and you start to see a pattern. A five-sided shape has 5 minus 2 is 3. 4 minus 2 is 2. A hexagonal shape, again, these polygons are named after the number of sides, also angles, will give us 4 triangles. And 4 triangles times 180 is 720. A 7-sided shape is starting to look like a sea monster here. Heptagon, hepta, 7, has 5 triangles. 5 times 180 is 900. So don't multiply the number of sides by 180. It's the number of triangles that are in there, which happens to be 2 less than all the sides, all the time. It's the same with the octagon as well. It has 6 triangles in it, giving us a sum, the total of all of these angles on the inside being 1080. So an n-sided polygon, this will be the sides will be n. n minus 2 will be the number of triangles that's in there. So our formula is n minus 2 gives us the number of triangles, multiply that by 180, and we have the angle sum, the sum of all the angles within that polygon. Polygons have to have straight sides, and they can either be convex, where all the interior angles are less than 180, or they can be non-convex, where at least one of these angles is a reflex angle. Now, I've mentioned before that polygons are named after the number of sides. So a 3-sided also has 3 angles. Polygon is a triangle. 4 is a quadrilateral. Then we get penta for 5, hexa for 6, heptagon for 7, and so on and so forth. So if we want to find out what a regular polygon is for each of these, they'd have to be regular, they'd have to have sides of equal length, and that would make their interior angles all equal as well. So looking at this regular octagon, each of these 8 sides is the same length, and each of these interior angles inside are going to be the same as each other. So it'd be really easy to use this formula for the angle sum of polygon. Angle sum in total is 8 minus 2, so there will be 6 triangles in here if we were to draw it out, times 180, and that gives us our total of 1080. Divide that evenly by 8, and you can find out what each of these interior angles is, and that works for any of these if they're regular. Same equal length of sides, and they will have equal interior angles. And again, this is that formula. The sum of the angle sum is number of sides minus 2, do that first because that's in brackets, multiplied by 180, because that'll give you the number of triangles. By 180 we get the angle sum. So let's do a couple examples. The angle sum of a hepta, first we have to realize that hepta is 7, a 7-sided polygon. So the angle sum is going to be brackets 7 minus 2, number of sides minus 2, brackets, times 180. 5 times 180, the angle sum of a heptagon is 900. So this is really handy if we want to find certain angles. So here I have a pentagon. Is it a regular pentagon? It is not, because it is not all the same size, and then therefore won't be all the same angles. You can see the angles are different. So if we're looking for A here, we need to know what the angle sum is for any pentagon, and then take away each of these known angles to leave us with what A is. So that's where we use the angle sum. 5-sided minus 2 is 3 times 180. The angle sum in total is 540. Take away 90, the right angle, 95, 170, and 80. Subtract all of that from 540, and we see that A is 105 degrees. It works. Finding the interior angle in a regular octagon. Remember, a regular octagon is all the same side lengths and all the same angles, too. That's really easy because we find our angle sum, 8 sides minus 2 gives us 6 triangles times 180. The angle sum of all the angles together will be 1080. And I divide 1080 not by the 6, so don't get confused. You divide it by the number of sides in total because you have 8 sides, or actually we have one here, or you'll find we have 8 angles. So the total angle sum of 1080 divided by the number of angles in this case, also sides, is 135, and that's every interior angle in there. Here's some practice.